In this section, I'm going to speak about the spanning tree protocol and the usage of this protocol in your network to prevent the loops that you may have in your network. So first of all, let me start with an example. Let's say PC1 is going to send a packet to PC2. What happens if I try to do that? If I initiate a ping, for example, from PC1, it sends a packet to switch 1. Switch 1 doesn't know anything about PC2, so it tries to send a packet on this interface and this interface, all its interfaces except the interface that it receives the packet from, right? Switch 5 is going to send this, for example, on this way, and this way. Switch 6 has received the packet directly from switch 1, and also it has received it from switch 5, so there is one problem here. Another thing is this: switch 6 doesn't know anything about PC2. Which side should it send it? Maybe that's a broadcast, so it may send it even back on this interface, right? If it doesn't receive anything from here, it may send it to this interface, or even send it back here, because let's see, this is directly connected to switch 6, so it receives to switch 6 a few milliseconds sooner than it receives from switch 5 to switch 6. So switch 6 is going to, for example, send the packet to switch 5 back, and also again it receives it from switch 5. So there is a loop, there is a problem here. Some kind of these loops are going to stop my network completely. For example, when I send a broadcast doesn't have a destination, a specific destination, of course. So this is going to remain in my network, and it is going to circulate in my network. And the problem is Ethernet packets do not have any time to live like an IP packet has. So IP packet, if it loops in a network, that's okay, because after some rotations, let's say 255 hops maximum, it's going to stop. It's going to be dropped. But here, Ethernet packet doesn't have any time to live, and it's going to be there forever. And a broadcast and multiple broadcasts are going to stay forever, and it's called broadcast storm, and very, very dangerous feature in your network. So what you need to do is to make sure that some of the interfaces are blocked. Some of the interfaces are not used, and these blocked state interfaces are going to just listen and check the network and monitor everything that is happening. They are not going to send or receive any packet from the other side, and the other side, of course, knows that this is going to happen. It is not going to send any packet on that interface. This is, of course, very, very essential in Ether channel links as well. And we are going to examine all of these in our lesson. So first of all, let's say when an interface goes to blocked mode, this is in blocked state. So I just write blocked state is one of the states of an interface. Now, a blocked state interface is not always blocked. It checks the BPDUs, the bridgeport data units that it receives, and based on that, it understands that it should be in blocked state. Let's say that it receives a BPDU that says that you should not be in blocked state anymore, or it doesn't receive any BPDU anymore. So in this case, it is going to transition. So this transition occurs after the last BPDU expires, and you know that the BPDU expire time is 20 seconds. So if it doesn't hear any new BPDU in 20 seconds that the last BPDU is going to expire, of course, it transitions to a mode that is called listening. So in listening, that is going to take about 15 seconds. It just checks the network and sees what is going on in their network. And after that, it transitions to learning state. So in learning state, that is going to take another 15 seconds. The switch is listening again, and also it is learning the MAC addresses that come and go, and it understands that, for example, what MAC address is on what port and what MAC address is accessible on what port, of course. And you can see that we have 20 seconds, 15 seconds, and 50 seconds, and all of them are going to add up to maximum of 50 seconds. So a network is going to converge in 50 seconds if it doesn't have its timers changed, and after that it goes to forwarding state. Of course, you can say that an interface has a disabled state, and disabled state doesn't have anything about BPDU. It may go to disabled mode because of the BPDU, but if you say that there is an error with the interface, any kind of error, that interface may be a disabled interface. But these are the actual phases that an interface goes through to start or start forwarding. Now you can change these timers, of course, and you can make sure that these are the least possible, because you know that your network cannot take 50 seconds of downtime, especially if the network has sensitive data, or for example financial data, or line of business application running in that. So you need to make sure that these are under 1 second, not 50 seconds. So we have, of course, some strategies to change this. We are going to speak about that later. But first of all, let me speak about something. I'm going to check the type of protocol that right now is running in my network. How can I do that? Just a simple command. It is show spanning tree. So by typing show spanning tree and hit enter, you can have information about all the ports on your switch that they are working right now. On switch 1, you can see that I have 3 interfaces running right now. If I check the topology, I can see that 2 of them are connected to distribution layer switches, and 1 of them is connected to a PC. I can see that each one of the ports has an ID, and I'm going to speak about that because this is very important to figure out the ID of the port. You can see that port 46 is going to be Fast Ethernet 1.5. There is no, meaningful translation between the port ID and the port name. Just that's a number, right? Port 51 is Fast 110, for example, here, and port 56 is Fast 115 here. And in the first part, it says that I have only one VLAN that is executing in IEEE mode. That is going to be .1Q VLANs. And also it says that the priority is about 32,768. And my MAC address is C201 and something like that. You can see that there are timers here configured. Hello time is 2. Max stage is 20 and forward delay is 15. We can change it with a simple command that I'm going to show you in a second. And you can see that I had 2 notifications, 35 changes, and this is normally my network because I had some configuration before I start this course, and all of them have changed my network. So let me see what kind of configuration I had. I just type show interface trunk, and you can see that some of the interfaces are in trunk mode, specifically Fast 1.5 and Fast 1.10. If I show for example my VLANs, it says that VLAN-S here, of course. I have only one VLAN, and that's the default VLAN, VLAN 1. I'm going to configure some VLANs, and I'm going to make sure that switch 8 is going to be my VTP server, and everything is configured on switch 8. Let's go to switch 8 and configure the VLANs right now. So if I go to switch 8, I'm going to go to configuration mode, and if I show VTP status, it tells me that I have already configured this. You can see that configuration revision number is 1. I have right now BTP version 2, and there is a domain name configured. The only thing I need to do is to configure the VLAN. So I'm going to just type VLAN 10, 20, 30, 40, and 50, and exit. And then I'm going to check my VTP status. You can see the revision number is changed, and right now I have about 10 VLANs. Some of them I just configured. So if I go to other switches, such as switch 1, now if I try to see VLANs, I can see that I have received VLAN 10, 20, 30, 40, 50, and this is what we have done in previous sessions. Now what I'm going to do is to check the spanning tree for all of these VLANs. I just type show spanning tree, and I'm going to just type brief. And of course these commands are a little different on different platforms that you have. You may just play around with all of those commands to figure out which one of them is going to give you such output that I am receiving right now. For each of the VLANs, you can see that it says one of the switches is the root switch. Right now it says spanning tree is enabled. This means that the normal spanning tree is enabled. The root ID is this, and the root switch is this. I don't know which one, of course, but based on the fact that it doesn't say I am the root, I know that this is some other switch, and all the timers that it has received, and its own VLAN, its own information is here. And of course you can see that it says C201 41D80005, which is my own address, so I am the root of this network. This is not good because switch 1 is in access layer. I'm going to change it, of course, later, but I can easily understand that this is me. And based on the fact that I just understood, I know that all the interfaces are going to be in forwarding state. For root switch, all the interfaces are going to be forwarding. You can see that here and also here, and that's it. These are the information that you can receive here. I just have show spanning tree summary. This is another command that I receive here. You can see that it says I have 0 interface in blocking mode, 0 interface in listening, 0 interface in learning, but 3 interfaces in forwarding. And all the 3 interfaces are running STP. STP is active on all of them. For VLAN 1, of course. For VLAN 10 to 50, again, I have all interfaces in forwarding mode. Let's check this information in another switch. Let's say switch 6. If I try to show spanning tree, let's say summary, it says that I have, for example, for VLAN 10, 2 interfaces in blocking mode, 8 in forwarding mode, and all of them, that is 10 of them, are running STP. So some of the interfaces are blocking, some of them are forwarding, and this is because of the fact that the spanning tree is working on all of them. Show spanning tree in this case is going to show full information about everything, every interface and every VLAN that I have here. So let's press Ctrl C. I'm going to stop this, and I'm going to see only information for one of the VLANs. Let's say VLAN 1 for one of the ports only, port 43. It says this port is forwarding for VLAN 1 and the cost is 19. We are going to speak about cost later. Port priority is 128. Again, we are going to speak about that. Port identifier that has number 43 after 128. This 43 is the port ID. You can confirm it by just checking this first part. It says this is port 43. And the priority for the root is 32,768, and the MAC address of the root is this, and every information that you can see here. For example, the number of BPDUs that are sent or received. So you know that each 2 seconds there is a BPDU. So right now you can say that how many BPDUs have been sent and received from the other switches. So these are very, very simple information about the spanning tree. We are going to continue in later sections.